Okay, welcome back to the last part of Unit 7. Real quick before we continue, there are word phrases. When I say 10 decreased by 3, what I'm saying really is 10 minus 3. And that's something in your book. I'm not going to really cover it so much here, but you'll find it on page 175, and there's some practice on page 176. It's practice 14. So actually, let me double check here, make sure that I'm not telling you the wrong page. Thought there was a real good one there. Okay, yeah, actually it's on page 164, and there's a really good chart there that gives you a hint about what those words are about. And so I want you to take a look at those and maybe practice those 1 through 10. It's not that difficult to understand, so I'm not going to really cover that here. But the last thing we're going to do is solving algebraic expressions. So if I take a number like 5, we're going to solve algebraic equations. 5p minus 4 equals 56. And if you've ever seen something like that on a test and you didn't know how to solve it, please pay close attention now. Remember how we use PEMDAS? Find a different color here. So if we're going to PEMDAS, we're going to do parentheses, exponents, multiplication, division, addition, and subtraction. When we're solving for an equation, we're not going to do that. We're going to work it backwards, and because we're undoing it. You know, when you're doing an order of operations, when you're combining your like terms, it's like you're tying your shoes. Well, we have to untie our shoes to solve and get p all by itself. As soon as we have p by itself, we have it solved. Okay, so we're going to work it backwards. We're going to SADMEP, is what I tell my students. And so the first thing we're going to look at, is there any addition or subtraction that we need to undo? Yes, there's subtraction. I have a minus 4. So what's the opposite of taking 4 away? What's the opposite of subtracting 4? Adding 4. We'll go ahead and we're going to add 4 to both sides. Remember, if you do something to both sides of an equal sign, the equation remains equal. 56 plus 4 is 60, and 5p minus 4 plus 4, that's the whole reason we added 4, is to get rid of that minus 4. So all that I have left is the 5p. I'm going to keep this equal sign in line. Now you'll notice I'm multiplying by 5. Opposite of multiply by 5, divide by 5. So I divide both sides by 5. 5 over 5 is just 1, which means I have p all by itself. And 60, that doesn't look like a 5, sorry. 60 divided by 5 is 12. So I find out that p equals 12. Then we take and double check our work. I'll take this 12, I'll put it back up here. Does it work? Well, 5 times 12 equals 60. 60 minus 4, 56. That does work. This is a fairly simple two-step equation to solve. And I want to look at something a little more complex, or a couple things that are more complex. So let's do one that deals with division instead, because for some reason that really throws people for loops. If I have x divided by 3 plus 2 equals 13. Okay, again, I'm going to SADMEP. So any addition or subtraction? Yes, I'm adding 2. The opposite of add 2, subtract 2. Minus 2, minus 2. 13 minus 2 is 11. And x divided by 3 plus 2 minus 2. Again, the whole reason I subtracted 2 is to get rid of the plus 2. All I have left over here is x divided by 3. Remember, it looks like a fraction, but it's just a division problem. Opposite of dividing by 3, multiply by 3. And I'm going to set it up so you can see what it looks like. Okay, let's multiply this side by 3, multiplying by 3. This side I'm also going to multiply by 3, but I'm going to make it look like a fraction. Well, I end up with 3 over 3, which is 1x. This is gone. Okay, so all I'm left with is x is equal to 33. Again, I can take this number, plug it back into my original equation to check my work. 33 divided by 3, that's 11. 11 plus 2, 13, that works. Let's do one more that's more complex. And if I have 2 times m minus 7 plus 3, let's see, equals 11. Okay? Again, I'm going to SADMEP, so I'm going to look at this and say, is there any addition and subtraction? Yes, there is. Remember, there's subtraction here also, but that's inside of parentheses, so I'm actually going to save this for last. The addition and subtraction that's outside of parentheses is the plus 3. Opposite of plus 3, minus 3. Minus 3 on both sides of the equal sign. This side leaves me with an 8. This side here I got rid of the 3, so I'm left with 2 times m minus 7 equals 8. Okay, opposite of multiplying by 2, divide by 2. Divide by 2. Divide by 2. And I end up with, I just have m minus 7 left. So actually, since that's all that's left over here, I've got 4 on the right side of the equation. Since that's all that's left, I no longer need parentheses. So when I rewrite it, I would rewrite it without the parentheses. Opposite of add 7, or subtract 7, add 7. Plus 7, plus 7, and m equals 11. Does that work? 11 minus 7 is 4. 4 times 2 is 8. 8 plus 3 is 11. Yes, that works. Okay, they might be a little hard to get used to, but after you get used to them, they're actually a lot of fun. I know that sounds weird, but even my students that hated it when they first started, they ended up loving doing this because it is a lot of fun and it's really easy just to undo everything and take a algebraic equation apart and solve. Okay, that will do it for this unit. Again, make sure that you have your assignment turned in, and if you have any questions, be sure to email me. If you need the extra practice, I highly recommend going to the units on IXL that I've got outlined on Blackboard. Have a good day.